So I'm presenting how to find optimal locations for infrastructure investment using GIS and CDA. And yes, as you already said, Mujam, this is a practical case. I worked together with my colleagues, Víctor Hernández and Ileana Grave, and my advisor, Luis Bojorquez. The case is the location of swine plants in Yucatan, Mexico. And let me see. Okay. Yucatan has a total area of 40,000 square kilometers. 70% of that area is natural cover or forest cover, and 50% of the total area is has been classified as a priority for conservation and restoration. Those are the areas that you are seeing in different shades of black-green. And in blue, you are seeing the wetlands that constitute 5% of the state. However, in the last 3 decades, 6,000 square kilometers of natural cover have been lost, mostly in the eastern and northwestern regions of Yucatan. Although we know that the transformation of ecosystems is a complex process, in this case, it can be mostly attributed to agricultural zones, urban sprawl, and swine plants. This has caused, unfortunately, the deterioration of environmental services and the increase of vulnerability to threats derived from climate change. So here the question is how to find those optimal locations for swine plant investments in a way that environmental conflicts are minimized. So to address this issue, we performed sectoral participatory workshops in order to develop AHP-based land suitability indices. The first one was of swine plant investment. We had around 60 participants that agreed that infrastructure, biophysical, and labor availability were the attributes that they will look for in the territory to invest. They selected criteria such as distance to electric networks, roads, to the main port of Yucatan, water extraction costs, and distance to rural and urban zones, for example. The second index was of environmental protection, and we had around 80 participants that developed this rather complex index, but they included several specific criteria for ecosystem protection and conservation, such as here you can see environmental services of support, provision, cultural and regulation, and ecosystem functions such as fragility, karsticity, and vulnerability of the water. So we then use the weighted linear combination to obtain the land suitability maps. This equation entails the importance weights obtained from the HP indices, then the normalized values of the land attributes in the territory, and some restrictions that were related to the prohibited areas by law or the vulnerability of the aquifer. But here we were looking for the optimal locations for infrastructure investments. So we also took into account the investment risk that has to do with the commission and omission errors inherent to any suitability analysis. As Gregor's just presented, we also took the attitudes towards risk, the seeker, the neutral, and the adverse attitudes. Here, I would say that they're related to, the risk, while the risk seeker would invest in any suitable area, the risk averse would rather just invest in the in the best ones or the optimal areas. So in order to address those attitudes in our analysis, we used the order weighted average by Malczewski. This entails the ordering the normalized values of the attributes from largest to smallest, and then reordering the importance weights according to those to their corresponding attributes values, and selecting a FOSSI set related to a linguistic quantifier. In our case, the FOSSI set was the attitude towards risk, and we varied the linguistic quantifier in order to obtain different scenarios of land suitability regarding the risk attitudes. These are the results, and then we obtained 3 scenarios for swine plant investment and 3 scenarios for environmental protection that range from an alpha value of 0.5, that was the risk seeker attitude. Then the neutral attitude was, well, the maps that we obtained at the beginning by the weighted linear combination with an alpha value of 1. And the scenarios of the risk averse attitude were the ones obtained with the alpha of 2. But since we were looking for the optimal locations for swine plant while minimizing the environmental conflicts, we decided to select the risk-averse scenario for the swine plant and the risk-seeker scenario for the environmental protection. So we then merged those maps using a rule-based model with the following rules. If the environmental protection suitability was very high, then the investment risks, were very high and high suitability for swine plant. If the environmental protection suitability was high, then the investment risks were very high and high for swine plant, very high and high suitability respectively. Else, the investment risks were very low and low for swine plant, very high and high suitability respectively. Finally, we obtain the optimal areas that minimize the commission errors for swine plant and the omission errors for environmental protection. That resulted in around 500 square kilometers with very low investment risk, and around 2,400 square kilometers of low risk. So in sum, they represent 7% of the total area of the state. And considering a swine plant of around 2 square kilometers, we would say that this area is enough to install like around 1,400 plants in the territory. So as conclusions, we could say that our approach does not identify the areas where swine plants should be built, but rather those areas that are more suitable and that should be considered in any planning process. This approach also extends the AHP and GIS MCDA modeling capabilities for environmental conflict. And finally, it is a tool for consensus building among stakeholders regarding environmental planning. So, thank you for listening.
Thank you very much. It was really nice last touch. Okay, thank you, Tatiana. Well, this was the last speaker for this session. Is there any question for Tatiana? I really enjoyed the talk, so interesting, the topic.
Thank you.
Well, any question, any contribution?
I'd just like to add congrats on integrating GIS and multi-decision criteria. So I enjoyed reading about it. Thank you.
Yeah.
Thank you. Thank you.
Thanks.
Me
thank
too.
you.
Thank you.
Yeah.
Me too. Thank you.
Thank you. I think I have to thank Gregor because he made us such a nice introduction for this application. So
okay.
They were also nice words.
Sure. Thank you very much for all the speakers and for all you friends who attended to this session of us. Now we have a 15 minutes break, and then there will be the next session. See you again. Bye-bye.
Thank you.
See you. Bye-bye. Thank you.
Ciao.